Bismillahirrahmanirrahim. Dear students, I welcome you all to Army Public School and College Fort Road, Rawalpindi online support program daily video lesson for mathematics class 10th, which will help you to solve the assignments given to you for week number 7. My name is Anila Nahid and I am from Senior Wing Girls. As we all know that we are following the Science Group Mathematics book for class 10, from which I will cover the topic of symmetric functions of roots of quadratic equation. More specifically, I will discuss exercise 2.4. The basic objective of this video lecture is that you will be able to evaluate a symmetric functions of roots of quadratic equation in terms of its coefficient, while the success criteria is evaluation of symmetric functions of roots of quadratic equation. Secondly, solving problems of exercise 2.4. So students, let us first discuss the recap. In the previous lecture, you have learned about the following cases that relates to the roots and coefficients of quadratic equation. We have discussed three cases in which the first one was about the relationship between roots and coefficients of quadratic equation. Second one was about the sum and product of roots of equation without solving it. And the third one was finding out the unknown values involved in the given quadratic equation, which comprises the five further cases. Sum of roots is equal to multiple of the product of roots. Sum of the squares of root is equal to a given number. Two roots differ by a given number. The fourth one was roots satisfy to a given relation, that is P of alpha plus Q of beta, while the last one was both sum and product of roots are equal to a given number. Moving on to the topic of the presentation, I will discuss about the symmetric function in this slide. So students, do you have any idea that what is a symmetric function? Basically, symmetric functions are those functions in which the roots involved are such that if we interchange the value of the root, the function remain unchanged. That is, f of alpha beta is equals to f of beta alpha. So if we interchange the position of the roots, the function remain unchanged. To discuss an example, let us consider a function f of alpha beta is equals to alpha cube plus beta cube plus 3 alpha beta. If alpha is equals to 2 and beta is equals to 1, then putting the value of alpha beta in the function, we will get 2 cube plus 1 cube plus 3 into 2 into 1, which will 8 plus 1 plus 6 and give you the answer 15. Now, if we interchange the roots and put alpha is equals to 1 but beta equals to 2 and putting the value in the function, we will get f of beta alpha is equals to 1 cube plus 2 cube plus 3 into 1 2, which will 1 plus 8 plus 6, and it will give you the answer 15. So student, did you notice that f of alpha beta is equals to f of beta alpha even if we interchange the roots? Therefore, alpha cube plus beta cube plus 3 alpha beta is a symmetric functions of the roots alpha and beta. Now come to the point that how we will solve exercise 2.4, which is to evaluate a symmetric functions of roots of equation in terms of coefficient. I am going to discuss three examples, in which example number 1 is that if alpha beta are the roots of the equation x square plus p of x plus q equals to 0, then evaluate alpha by beta plus beta by alpha. Solution is, since alpha beta are the roots of equation x square plus p of x plus q equals to 0, so sum of the roots, that is alpha plus beta equals to minus p, while products of the root equals to alpha beta equals to q. As we know from the previous lecture that the formula for sum of roots is minus b by a and the formula for products of roots is c by a. First of all, simplify the given symmetric function by taking the LCM and we will get the following expression. Now students, if we notice the numerator, it's alpha square plus beta square and we don't have the value of alpha square plus beta square. So we will use the formula alpha plus beta whole square as alpha square plus beta square plus 2 alpha beta and convert the expression in truly of the form sum and the product of roots. Putting the value of sum and product from the previous slide, we will get the following expression. And on further simplification, we get this. So here the question is being solved and we get the final expression as alpha by beta plus beta by alpha is equals to p square minus 2q divided by q. Let us discuss example number 2, which is if alpha beta are the roots of equation 4x square minus 5x plus 6 equals to 0, find the value of 1 by alpha square beta plus 1 by alpha beta square. Moving on to the solution, we have to find the sum and the product of the expression. So, applying the formula for sum and product, we will get alpha plus beta equals to 5 by 4, while alpha into beta is equals to 3 by 2. As b is minus 5, c is 6 and a is 4 in the following expression, and we will use the same formula as I have discussed in the previous slide and we have learned about it in the previous lecture. Simplifying the given symmetric function by taking the LCM, we get the following expression. Now if we take alpha beta as common from the numerator and express the denominator in the form of a perfect square, then putting the value of sum and product of the roots from the previous slide, we get the following expression. So after simplification, we have solved the question as 1 by alpha square beta plus 1 by alpha beta square is equals to 5 by 6. Let us discuss example number 3, which is if alpha beta are the roots of the equation 3x square plus 2x plus 7 equals to 0, then evaluate alpha square by beta plus beta square by alpha. Moving on to the solution, we have to find the sum and the product of the following equation. Here a is equals to 3, b equals to 2 and c equals to 7. So alpha plus beta equals to minus 2 by 3, while alpha beta, which is product of the root, is equals to 7 by 3. And we have applied the same formula for the sum and product of the roots. Now, simplifying the given symmetric function by taking LCM, we get the following expression. If we notice, the numerator is alpha cube plus beta cube and we don't have the value of alpha cube plus beta cube. So expressing it as the form of sum and product by using the formula alpha plus beta whole cube equals to alpha cube plus beta cube plus 3 alpha beta into alpha plus beta. Putting the value of sum and product from the previous slide, we get the following expression. So after simplification, we have solved the question as alpha square by beta plus beta square by alpha equals to 118 by 63. Your assignment is to solve exercise 2.4 and I hope that these 3 examples would help you to solve these questions. Thank you so much students for your time and attention.